Hey, welcome to lesson number 6, graphs of the other trig functions. That would be tan, secant, cosecant, and cotangent. So I'm going to let you guys pause the video right now and copy down tan and secant. Okay, so real quick, let's talk about some pretty important stuff here. Okay, you'll notice with tan that all the really interesting stuff was happening at half pi increments. We want to keep that in mind for any kind of horizontal shifts or any kind of period change, making it wider or shorter. Okay, so that's important, half pi increments, right? And then hopefully what you notice is that with tangent, we started at 0 and we went up on the positive side, right, this way, and went down on the negative side. And that change repeated, right, over and over, but it happened at 0. So what we would want to think of our average line, right? So when we had any kind of horizontal shifts, that means that these points where things change direction, that's what's going to be affected on the horizontal shift. Okay? And then secant, you might have noticed that it said it's based off of cosine. You might have also noticed a pink dotted line. That's because this pink dotted line is cosine. So what we're going to be doing, and you'll see in our game plan in a little bit, is that we're going to sketch cosine first. And hopefully what else you might notice now is that anywhere that cosine hit that average line, we're not going to have an asymptote. That's because secant is the reciprocal function, right? And you can't take the reciprocal of 0. That would be dividing by 0. So that's where we get these asymptotes from. Okay? And you'll notice that it's really just a whole bunch of weird looking U shapes that are trapped inside. That's because cosine goes this way, and we want it to be kind of mirrored, that reciprocal look. That's why secant has that U shape to it. Same thing with cosecant, but you'll notice it's based off sine. So copy this down and just keep all those things in mind that we saw up here happen here. Okay, let's move on. Our final graph of the day is cotangent. Copy that down, and we'll talk about it in a second. Alright, so cotangent, you should have noticed, looks really pretty much like tangent. But the big differences are, instead of us starting at 0 and having our asymptotes at the halfway mark, cotangent has its asymptote on 0, and it's every full pi unit where those fall. And then at the other half pi increments, that's where the function changes direction. But what do we notice about tangent is that it started negative and then went up. We want cotangent to be flipped because it's a reciprocal, so it should be going down, just like this. Okay, so that's what we want to keep in mind. Still got those half pi increments, but we're starting at 0 instead of the negative half pi's. Okay. Then you have this game plan for graphing. Right? Our first step is we're going to sketch in a ghost version of sine and cosine. Not all of tan. We're going to, in fact, just put down those critical points. Okay? Why? Because as we mentioned above, everything happens at half pi increments. We just have to figure out if we're going with tan or cotangent. So these ones, it's important to sketch in that ghost, that dotted line. Tan, not so much. Next, we're going to sketch in the asymptotes, right? Wherever we need them, we're going to put them. And where we need them is where sine or cosine hit 0, right? That average line. So we're going to sketch those in. And last, we draw in the appropriate secant, cosecant, or cotangent functions, or tangent for that matter, okay? But these ones, because they're the U's, right, we want to see what this looks like first before we get those in there, okay? Kind of like a buy one get one free offer. You sketch in sine and cosine, what that's supposed to look like, and then you get secant and cosecant for free. So let's try some. They ask us in the first problem to do half of cosecant minus 1. So some pretty important things are happening here, right? We have a vertical shift, -1. that means we've got to drop down. Instead of us being at 0, we're down here at -1. And we have an amplitude change. Okay, but we're still going to be working with the same period. So it's still going to be just as wide, no shift or anything. So let's first, and we'll do this in light blue, we're going to sketch in not cosecant, but we want to work with the opposite, which would be sine. So we're going to sketch in sine. Okay? So I need to move my vertical, I'm sorry, not my vertical, my horizontal starting point, my average, down 1, right? So that was just taken care of. With sine, we start at 0, and there's no left-right shift. So we're going to start here. Instead of going up a full 1 unit from that average, I only need to go up half. And I know that I go out to half pi, so I should be going out here to half pi. And then I'm going to go down back to 0, right? And then down a half pi unit, and then back to 0. Well, actually, that's not a half pi unit, it's just a half unit. Anyways, okay, so we've taken the time to sketch in sine. And I'm going to draw on these dotted lines. You don't have to draw these in. It's not mandatory. But it does help when you go to look at the rest of it. Okay. Next, we want to draw in those asymptotes. Right? So anywhere that our function hit 0 line, or our -1 for this, that's where those asymptotes go. So I'm going to draw them in real quick. We're over the axis, so I'm going to draw them in diagonally so it can see them a little better. And this is why we draw in the little ghost sine here, rather, right? Sine function, because I know that I'm going to be sharing that same point right here, right? That minimum value. But I want this thing to be reciprocal. So sine here is going like a U, so I need my reciprocal to be upside down. So it's going to be looking like that. And then I'm going to start up here, and I need to go the other direction, so I'm going to go up. Never crossing the asymptotes. And you can even imagine that you'd have a little bit coming like this too. Okay, so that was cosecant, right? Really wasn't that difficult because we were just doing the same thing as yesterday's lesson with sine, just drawing that function, worrying about any kind of amplitude change, stuff like that, right? And then we sketched in cosecant from it. Now we got one that's working with cotangent. This one, though, is telling us that we have a reflection and a vertical shift up +1. So now let's think about it. Tangent is the one that we really wanted to work on, and we said all the interesting stuff happened at half pi increments on the 0, right, average, right on the x-axis. But we're moving that 0 average up 1. So I'm going to be putting major points at every half pi increment at 1. All right up here. And we want to remember some important stuff, right? For tan, we had those asymptotes at the half pi's. Cotangent, it was right here on the axis and every whole pi. And because there's no period change and no horizontal shift, they're just going to be on every whole pi. So we can draw those in. Okay, so those weren't too bad. What we want to think about now is what tangent looks like. Tangent starts negative, hits this middle point, and then goes positive. But we're working with cotangent, so it should be going opposite. It should be coming down, hitting the point, and then going down again. But we also have a reflection. So instead of it going from top to bottom, it's going to go from bottom to top. So we start from the negatives, we go up, we hit that middle point, and then we go up from there. And then we just repeat it. And in fact, this pattern is infinite. So we're going to repeat it either until our computer dies or the person who's drawing it by hand dies. That's how long it goes on for. But we can stop though, because we were told to go from negative pi to 3 pi, so we don't have to go on for infinity. Okay, we've got one more for you to try. It's from negative pi to 3 pi, so don't take too long with this one. Right, you're working with 2 times secant of x minus pi over 2. Pause this video and resume when you're ready to check your answer. Alright. We're not working with secant to start with. We're working with the reciprocal, which is cosine. So we're going to do all the stuff that works with cosine. We have no vertical shift, so we're still working average height on the x-axis, so that's taken care of. But we do have an amplitude change, right? So instead of us going up to 1 from 0, we need to go up to 2 and down to negative 2. So let's keep that in mind. The only thing that's really shaking us here is that we have this negative 1/2, right? So we got to shift everything half a pi unit. Now, cosine starts at 1, but I've got to double my amplitude to 2, and I've got to shift over half a pi. So that's where we're going to start. And then usually cosine comes down to 0 at the half pi, but because I've already shifted over, I should be going to the next half pi. So I'm down here. And then it's going to go the next half pi unit and go to my minimum, which would be down here at negative 2. And then it comes back up, and then it comes back down. Right? On the other side, it's going down here. Right? So that's what it's looking like. But we have this average line right here on the x-axis. Anywhere that I see a blue point, I'm going to put my vertical asymptote. I'm doing that right now because last time I forgot to, and I messed it up. So I'm going to do that right away so I don't have to remake this video for a third time. Okay, now think about it, right? Cosine's doing this. Right, that's what cosine's doing. But we don't want cosine anymore. We want the reciprocal. So I got to start down here, and I've got to kind of go a lot sharper than usual. Right, it's going straight down. And then over here, it's doing the same thing, right? But it's going backwards. It's coming up. Right, so here we go. Going down like that. Going up. Maybe a little piece over here that we might be able to see. Okay, but that's really it for that graph. So you had all of this that you definitely needed, but this is what the actual function secant is looking like. These u's right here. Okay, so that's it for that lesson. The reason why it's so short and there's not too many more examples is because you're really just graphing either sine or cosine, or you're worrying about a couple of critical points, right? If we had any kind of period change, then these things would stretch, but we didn't have to worry about that, right? It was just some pretty basic stuff that we worked with from last lesson that we just applied to for these new guys. Okay, so we'll move on to the next lesson, which is going to be more trig. So we'll see you there. Bye.